Hello, everyone. Our mobile app is called Jumbled Jungle. I'm Annabelle, the specialist, and I study vision and cognitive perception in the psychology department. My teammates, Saeed and Dong, are programmers in the ECE department, and today we'll begin with a skit to introduce our application. Hi, Saeed. Thank you so much for agreeing to participate in my experiment.
Hey, Annabelle, sure, no problem. Seems like everyone is having a hard time right now with the quarantine, collecting data.
Yeah, it's been a bit of a nightmare, but at least we can run our study offline since it's a mobile application. Since you downloaded the app already, would you mind just sharing your screen so I can walk you through it?
Sure, sounds good. So just tell me just a little bit about what you're studying.
Yeah, so we're looking at the ability of the visual system to represent objects as a group instead of individually. If you go ahead and click on that settings button, I can show you an example.
Okay.
So just go to how to play.
Okay.
Great, so you can see that each tree has a group of fruits. Well, our visual system can quickly figure out the average size of the fruits in that group, even if there isn't enough time to figure out the size of each one individually. This ability is called ensemble perception, and there's still a lot we don't know about how it works and how it changes over the lifespan. So I'm running this experiment to test how age and other individual factors may influence our ability to form these group perceptions. So explaining this task a bit further, what I want you to do is to choose the tree you think has the larger average fruits. So in this case, it's the one on the right, so you can go ahead and tap that.
Okay.
And if you choose the wrong option, so for example, the tree on the left, then you'll lose a stamina counter. And once you lose all of your stamina counters, the game is over.
Okay, it's easy enough. I think I'm ready to play.
Great, so you can go ahead and hit the play button. And here you can select the user who is currently playing. You mentioned that one of your family members might want to try the game, right?
Yes, actually my cousin was interested, but he's worried about sharing his data, so he may not be willing to share his personal information.
That's no problem. So he can always choose guest, and then we won't record any of his personal data. But if he wants to sign up as an actual participant, you can just add him with the little plus button in the future, and just make sure you answer all the questions.
Great.
Okay,
I just noticed, yeah, we have more fruits and more characters.
Yeah, as you play the game, you'll unlock more points, so you can get those characters later. So if you're ready, you can go ahead and start the game.
Yes, I'm ready. All right, so I'm gonna play. I already know how to play, so I think this has the larger average size. Right for left, now I think it's this one. In the right. Now I think it's this one. One thing I noticed is that once you advance, seems like the sizes are becoming very similar sometimes. So,
so you can go ahead and hit pause. So it's perfect if you understand the task just fine.
The challenge.
So we can just quit the game and go back to the main menu. The last thing I wanted to show you was the performance in your data. So go ahead and click on that data button in the bottom.
Yeah, that was exactly what I was going to ask.
If you're interested, you can always export your data to look at it, but there you just have some graphs for your results. And if you're interested in more information about the application or you wanted to reach out to us, we have our information in the credits under the settings as well. But other than that, I think you're all set.
Great. Thank you so much for showing me this, Annabelle.
Okay, no problem. Thanks for playing your game. Bye.
Thank you. Bye.
Okay, so I hope you guys enjoyed that little skit. Our motivation, in case you missed it, is to create a mobile game in order to collect data on how quickly and accurately individuals perceive the average size of a group of objects. And we're doing this to provide a direct replication of a previous study outside of the traditional lab setting. Hopefully this will result in a large database that will link study performance with biological factors of the users, such as age. And finally, we hope to create an engaging experiment which will encourage participants to focus during the task or enjoy playing it over a longer period of time.
So before the game starts, users can learn how to play the game from our tutorial. A new user can register an account with the demographics data, which will be sent to our Google Firebase. When the game starts, our algorithm will randomly generate fruits with different sizes on the screen. The fruit will appear to be on 2 trees, and then the user is supposed to make selections. The algorithm increases the difficulty of the game based on evaluation of user performance. The user will be directed to the results screen after failing a trial or completing the last level of the game. Once the user finishes the game, our app will create plots and shareable CSV files for research use. Okay, next. In each round, both of the left and right trees will have 8 fruits. The average sizes are set by us, while the individual sizes are randomly generated within a specific range. Like for example, here, the average sizes of the fruits in the left tree is 10.5, while it's 7.9 for the right tree. They can't be equal, otherwise there's no right answer. As we level up, the average sizes of the 2 groups will be set closer to each other, so that the next level can become more difficult. For example, here the mean size of the left tree is reduced from 10.5 to 10, and the right tree increased from 7.9 to 8.4. Okay.
Okay, so for future work, we have mainly 2 categories. For the game itself, we would like to make the game available for platforms such as iOS. We also would like to add more languages, so for reaching a wider audience, and also have some community presence on the online gaming, so we can share and compare the performance, speed, and achievements. And from a research standpoint, we would like to create a more Excel or CSV-friendly application in the web, so for data exploration. And we also would like to make an open source design mode so researchers can modify our game for their own experimental paradigms. And finally, implementing some privacy and data use policies in case people want to know what's going to happen after with the data.
In terms of our key learnings, the first thing is that we would hope to focus on the fun a bit earlier next time. So when we first got started, we were very focused on making a mobile port of the experiment exactly, when it would have been, I guess, more useful to focus on the fun game-like aspects of our app, which make it unique. Secondly, everything has a trade-off. So it was very hard for us to find the perfect balance between the time and effort put into the game and the quality of the final product. If we had the chance to start over, we would probably opt to make something a bit more simple, but robust enough to be considered a minimum viable product. And finally, plan for the worst case scenarios. So working on presentations and reports as a group was a really great learning opportunity, and we want to thank the teaching team and all of our classmates for their feedback. So here are our references. Thanks again for your attention, and feel free to try our game and give us feedback if you want on the GitHub repository.
Thank you. Time is up. So that's good. It was a really good skit that gave us some sense of what was going on, after which you did the motivation. That was really great to see. And you've added a bunch of features, lots of extra fruit, pausing, and data exploration. One quick comment that's maybe more relevant for your final report: when it comes to describing the structure of your software, that what you did here was a mixture of function and structure, and that's supposed to be conveyed in the demo. In the final report, you're supposed to convey it in the screenshots and all the rest. You don't describe function, it is structure. And if you're not sure about that, we'll have to have a conversation. So don't mix structure and function as much as you did. I had a question about the data that you were displaying. What is it? Can you show it again? The data, that's the summary data. It's a bunch of charts, but you didn't tell us what it was.
Yeah, so we were a bit crunched on time, but basically the graphs that we show here, it's accuracy values. So basically out of however many trials the participant completes, which ones do they get correct? So it's just a percentage correct value.
And what would someone use that for? Like I'm the user at the end, I'm not the researcher. What do I take from this? Or is there something I would learn?
So as the user, that accuracy value of how many trials they get correct directly corresponds to the points that they're getting and how well they do in the game, basically. So as a game performance measure, that's useful for the user, and then for the researchers, this is also the main measure that we use when we look at someone's ability to perceive those sizes.
So, but is there it seems to imply that there's a training effect. Is there?
The research, no one has really looked at longitudinal, like so over time, how people might improve in ensemble perception. So this would be purely exploratory, but hopefully there will be some sort of training effect.
I see. And if you were going to recruit people for this, how do you have any idea how you would recruit them? Because it's a research methodology.
So one of the most important things when it comes to recruiting the participants is getting that privacy policy done smoothly within the app. So what we would originally do is not collect anyone's personal data. And then after they've tried maybe like one round of the game, we might let them know that this is for a research study. And if they're interested in sending us their data, that they should read, this or talk to one of us. Yeah.
So I understand that, but my question is, how are you going to get those people in the first place?
There's lots of options. If this is an app on the App Store, obviously we could reach a bunch of users, but otherwise within our own labs, we also have lots of repositories for participants that we can reach out to.
Okay, this is beyond the scope of the course, but I was just curious. Good, well, great work. It's great to see a real research-oriented project come to fruition. Dan, any questions?
Yeah, so in the original methodology, how are the fruits being presented visually to the user, like on a piece of paper?
No, that is done on a computer screen.
Okay.
And I'm not sure if you remember, but in our first presentation, we showed you a screenshot of what their image looked like, and it was just very basic, 2 trees,
Yep.
a jungle, and then the monkey. So they do the same thing, but strictly on a computer.
So it's not, this wasn't necessary for your project in the course, but if you were to continue this going forward, what considerations would there be for reproducibility from a scientific perspective, given that you can support different devices and stuff like that?
One of the big things that we were worried about is making sure that when we're porting from different mobile devices, that we keep track of the resolution, because the actual size of the object on the screen and how far it is from the participant really matters when you're looking at psychophysics or how people's vision works. So that's something that we would have to keep track of.
Okay. Does the monkey get sad if you lose the game?
I thought that would be too mean, so I didn't do that, but we could. Yeah.
Thanks.
Yeah, I just had a quick question as well. So does the orientation of the fruit on the tree make a difference in the ensemble detection?
So in this case, we are just using round shapes as oranges. I know some of them you saw had a shadow, but if we were running this in an experiment, we'd probably take the shadow away, so it was just the circular object. Ensemble perception actually works across many visual domains, so we can look at things like average orientation or average speed and motion and all sorts of things as well. But for this case, the base case, we're just looking at the orange sizes. So orientation wouldn't matter.
Right, but like relative to where they are, relative to each other, where they are on the tree doesn't actually make a difference.
We're currently following the same paradigm as was outlined in that paper that we spoke about. However, if the objects are too far apart and they're not considered in the same grouping anymore, that could affect ensemble perception.
Okay.
And there's a lot less research on that because most of our research is done on that computer screen and there's only so far apart you can move the objects.
Right.
So I'm not sure is the short answer.
Great, thanks.
Thank you.
Any questions from anyone else? Amazing artwork. Is that the previous one or this one? I can't remember. Okay, thank you very much.